Okay, now here's the second questions. A transverse wave on a string is given by y equal to 2.4 cos. Okay, this is a cosine equation. These are the things you need to take note, because this is a cosine equation. Now, pi over 20. Oh, here's another bracket again. This one you need to multiply inside. Okay, you need to multiply inside before you do any further action. Always expand first. Expand. Yeah, and this time it is a bit strange, because the the equation. Wait, the equation is x here and t here. It's become like something like equation like this is a kx minus omega t. Okay, because our general equation is omega t first, then only kx. This one is kx, then only omega t. Okay, but if 40 is not omega, you need to multiply inside, expand first, then only get omega. So be careful. Yeah, so kx minus omega t. So pi over 20 times 0.5x minus 40t, where x and y are in cm. Okay, and t in second. This is also very important about the unit. X and y in cm and t in second. Calculate the maximum particle velocity. The particle velocity. Okay, before we go any further, first of all, we arrange the formula first into the general formula. So we have, I rewrite here, we have y equal to 2.4 cos. Okay, I already expand, yeah? So this one I expand inside, multiply inside. So I get, let's say, pi over 20 multiply 0.5. So I get 0.025 pi x. Okay, you must expand first, yeah? And then pi over 20 multiply inside, I have 2 pi. Okay, pi over 20 multiply 40, I get 2 pi. So 2 pi t. So I compare this equation with y equal to a cos. Yeah, I use cos. And in front of the x must be k. In front of the x must be k. In front of the time must be omega. So it is kx plus minus omega t. Our syllabus, we are using omega t plus minus kx. But this one is kx plus minus omega t. So be careful, exam sometimes this kx and omega t can interchange the order. Yeah, kx can be in front, omega t can be at the back. Yeah, or omega t in front, kx at the back. So it can change. So you must be alert of this. Okay, so from here I can see my amplitude is 2.4. What's the unit? That's why the unit also important. X and y in cm. That means the y in cm, the y in centimeter, the displacement in centimeter. So the amplitude also in centimeter, because the amplitude follow the y. Yeah, amplitude unit follow the displacement unit. If amplitude follow the y. So if y is cm, a is cm. So this is 2.4 cm. Okay, not 2.4 meter. Okay, 2.4 cm. And then he also say x in centimeter. X in centimeter, that means the wave number is per centimeter. Per centimeter. So later on, I know that the wave number you get wave number later you can get lambda, isn't it? Because k is 2 pi over lambda. 2 pi over lambda. So if x is centimeter, so k is per centimeter. That means your lambda is also in centimeter. Okay? Because k is per centimeter, so your lambda is centimeter. Okay? And then how about the omega? So your time is in second. Time is second. So my omega is per second. So that means from omega you can get frequency, you can get period. Period. So my omega is per second. That means my period is in second. Imagine if the time is millisecond. If the time is millisecond, then my period must be in millisecond. Because if time is millisecond, then the omega is per millisecond. Yeah, per millisecond. So my period is millisecond. So the unit is the most important. Okay, be careful with the unit. All right. Now let's back to the subject. Now I want to find out the maximum particle velocity. What is particle velocity? Before this, you learn about another formula. You learn about wave speed, isn't it? What's the difference with particle velocity? Wave speed with the formula V equal to F lambda. V equal to F lambda is to find the speed of the wave propagation to the left or to the left or to the right. That is the speed of wave propagation. The whole wave. How fast the speed, how fast the wave propagate. And it is always constant. I just want to revise with you. Wave speed is always constant. The wave move at constant speed, propagate at constant speed. Particle velocity is the vibrational of the vibrational velocity of each particle oscillating up and down, up and down, up and down. We know that the whole wave consists of many particles, all oscillating up and down, up and down. It has many particles, all oscillating up and down. So at different displacement, they have different velocity. They all oscillate like the spring mesh system, the block oscillating up and down, up and down. It's just the same as spring mesh system. Okay, they oscillate. So the particle velocity actually is the vibrational velocity of the particle oscillating up and down. That's what the question asks for, the particle velocity. So it's not about the wave speed. It's not the wave speed. It's about the vibrational speed, vibrational velocity of particle up and down. That one is not using F lambda. Particle velocity, we not use F lambda. Particle velocity, we differentiate. We need to differentiate from the displacement time equations. Same like the simple harmonic motion last time. Still remember? We have the x time. Still have to remember the simple harmonic motion, the spring mesh system. To find the displacement, we use xt equation. And then to find the velocity, we use velocity time equation. To find the velocity, we differentiate from the displacement equation. Remember or not? To find the acceleration time equation, we differentiate from the velocity equation also. To find the vibrational velocity and the acceleration of the block. So we use back the same thing here, yeah? We are talking about the same thing here. So we are talking about particle velocity. We need to differentiate from displacement equation to get velocity, differentiate from velocity equation to get acceleration. That's what we're going to do. We're not going to find V equal to F lambda. Okay, we want to find the particle velocity. So we need to differentiate. But first of all, it asks about the maximum particle velocity. This is the same as the spring mesh system last time. Maximum particle velocity happens at A omega. Remember? Remember the three things? Maximum displacement. Maximum displacement is amplitude. Maximum velocity is A omega. Maximum acceleration is A omega square. Remember this? We are going to use that. So to find the maximum particle velocity, it is A omega. So what is our A? What is our A? We already got A is 2.4. What you need? Don't put meter. This amplitude is cm. Why is cm? Don't make me explain to you again. Yeah? Don't make me explain to you again. Amplitude always follow the displacement equation. It always follow the, the unit given in x and y in cm. So my amplitude is cm. Okay, amplitude is in cm. So it's not meter. And then my omega is remember you must expand first. Expand on, don't put omega 40. Omega is not 40. It's after you expand out, which is 2 pi. So my omega is 2 pi. Omega is 2 pi. And the unit is per second, not millisecond. It's per second. Okay, so multiply and I get 4.8 pi. Unit is not meter per second, but is cm per second. Remember the unit, don't get it wrong. Which is also 15.08 centimeter per second. That's the answer. Okay, that's the answer. The maximum speed. And this maximum speed happens at the equilibrium position. When the particle reaches the y equal to 0, which is at here, the equilibrium position, the particle has the maximum particle velocity. Maximum particle velocity, a omega, which is 15.08 centimeter per second. Yeah, at the equilibrium, at this line over here. Okay. When the particle go to the amplitude, velocity becomes 0. All right. Very clear, my explanation. Now, okay, what's the particle velocity at this particle? Okay, this will give the position or distance 1.5 cm, and at this time. So what is the velocity for this particle at this time? How to find? So to find velocity of the particle, you need to differentiate. Velocity differentiate from the displacement equation. Differentiate to get the particle velocity. So to differentiate, I already have the displacement time equation, which is this one. This one. Okay, this is the displacement equation. This is the y versus time equation. So I want to differentiate this displacement equation versus time to get the velocity dy over dt. So why we must differentiate? Isn't that in the list of formula we have available velocity formula for us to use directly? Why bother to differentiate? Why bother to learn about differentiation so hard? Yeah. Whatever I teach, there is a reason behind. So don't ever think what I teach is not important. It's very important. All right. So there's a reason behind why I teach you how to differentiate. You know why? Because in the syllabus, it just gives you only one formula. In the list of formula he provide you, the displacement equation start with sign equation. It is a sign equation. For the displacement time equation, for the displacement equation, it provide you with only sign. It provide the list of formula or our syllabus only provide you with the sign equation for the displacement equation. We don't have the cos. We don't have the cos formula for the displacement, but this question is cos formula. So in the list of formula, it gives you the displacement with sign equation. So if you differentiate, you will get velocity equal to cos. You get cos. You get cosine formula for velocity. We cannot use this velocity formula. We cannot. Because our displacement equation is start with cos, not sine. If the question start with sine, if the question give you is start with sine, then of course you can use this velocity formula. You can use this velocity formula. Can. But now if you give me the displacement equation with cos formula, you cannot use this equation because we know that differentiate cos, you get negative sign, not cos. So be careful. This formula, available formula in the list of formula, can only be used if the displacement formula is a sign formula. So, if the question gives you the displacement formula with cos, then you need to differentiate yourself to get the velocity formula. So, you need to learn what I teach you. All right. So my displacement equation is 2.4 cos, so on, 2.4 cos. This is the formula for displacement equation. So I differentiate with time to get the velocity. Okay, step by step. Actually, this is the differentiate the trigonometry is a mathematic knowledge. This one you must ask your mathematics lecturer to learn more about mathematics, how to differentiate. Okay, this is your task to go to find out how to differentiate a trigonometry. Yes. Now, okay, never mind. I teach you a bit of tricks. To differentiate the cos, first of all, we differentiate outside, then we differentiate inside. This is actually the chain rule, but I'm not going to go detailed into chain rule. Yeah, I'm going to teach you the fast method. So I hope you understand what is chain rule before you do this. Chain rule, you know what is chain rule? The chain rule in the differentiation. Okay, that is your task to find out, not me. Yeah. Okay. So to differentiate first of all we differentiate outside, then only we differentiate inside. Okay. So first of all we differentiate. Okay, 2.4 no need to differentiate. Just put out. We differentiate the cos. You get negative sign. Okay. And then the rest you just copy, and then we differentiate inside. We have, this is the omega t. You differentiate, you get differentiate the negative 2 pi. This one differentiate, this one with x, you differentiate, it becomes 0. Yeah, because we differentiate with time. If we differentiate with time, this one becomes 0 because this one becomes like a constant. Okay, and then you differentiate the negative 2 pi t, you get the negative 2 pi. Because t become power 0, power 0 become 1. Okay, so negative 2 pi. So the negative also, don't forget, the negative also you need to write down. Don't just take the 2 pi, the negative also must include. Okay, negative 2 pi, the whole thing, negative 2 pi is the constant. The negative 2 pi here, and t become power 0, just disappear. Okay, then after that you just this negative 2 pi multiply to the front, yeah, like in simple harmonic motion. You just multiply to the front, and what do we get? Negative 2 pi times 2.4, you get okay, because here we have negative already, isn't it? Here have negative, so negative times negative, you get positive. And then 2 pi times 2.4, you get 4.8 pi. And then the rest, sine omega x, sine kx minus omega t. Okay, so you get the velocity formula. This is the velocity versus time formula. Okay, now so the next is he asked to find the velocity for this particle at this position 1.5 cm, and also at this time. So what is this velocity for this particle at this time? So you just substitute inside. Just substitute into x and into time. Just substitute inside. Okay, let's do it. So we substitute. After we substitute, yeah, don't forget your calculator is in radian. Yeah, don't forget your calculator in radian. Everything must be in radian. Understand? Must be in radian. Don't put degree because it's pi. Pi is 3.142 radian, isn't it? So it must be in radian. So substitute inside, and then you do the substitution. Okay, substitute the value, and in the end you will get negative 14.98 What's the unit for this velocity? We are using, because our maximum velocity, Vmax A omega, our A omega is cm per second. Cm, you know, is cm per second. So our velocity is cm per second, not meter per second. Be careful. So, and then negative means it's going downwards. Yeah, the direction is going downwards. Okay, that's the direction. So that's the particle velocity for this particle at this time. Okay, it's correct. Yeah, negative 15. Yeah, almost there. Now, what is the maximum particle acceleration? Maximum particle acceleration is just A omega square. A omega square. So, yeah, maximum acceleration is A omega square. This happened at the amplitude. Remember, the acceleration is proportional to the amplitude. The higher the amplitude, the higher acceleration. In the simple harmonic motion, we learned that. So acceleration is maximum at A omega square. So it happened at amplitude. Now, what is the, first of all, I need the amplitude. I need the amplitude is 2.4 cm again. So it is, sorry, this is, oh, sorry, what happened? Okay, please bear with me for a while. Okay, my amplitude is 2.4 cm. 2.4 cm. Cm, yeah? Not meter. My omega is, my omega is 2 pi. My omega is 2 pi. So square, so what do we get? I get 94.75 centimeter per second square. So my acceleration also centimeter because my amplitude in centimeter. Per second square. Yeah, second square. Sorry. So this is not per second. This is per second square. Yeah. All right, that's my maximum acceleration. Now I want to find the acceleration, the particle acceleration for this particle at this position, 1.5 cm, at this time. Okay, so that means I need to differentiate again. Yeah, A equal to dv dt. I need to differentiate the velocity equation again. Yeah, differentiate again. Differentiate from this equation. Yeah, this is the equation, velocity equation. I differentiate with time. So how to differentiate? Yeah, first of all, 4.8 pi remain. Differentiate sign, get cos. And then the rest, you copy. And then differentiate inside, you take out the negative 2 pi. Take out the negative 2 pi. Remember the negative. Don't left behind. The negative also, you must include here, negative. Okay. And then after that, you multiply negative 2 pi to the front here. And what do you get? Negative, you have negative 2 pi times 4.8 pi, you get 9.6 pi square, and then the rest. Okay? Then you get this formula. Now you just substitute the x with here, and then the time also you substitute. Okay? Substitute. Remember everything in radian. Okay, and then yeah, so just get the answer after you substitute. You use a calculator. The answer you will get is negative 11.14 centimeter per second square. Yeah, again, because why centimeter per second square? Because our A maximum is centimeter. Because our maximum acceleration is centimeter per second square. So the acceleration just follow the unit, centimeter per second square, and the direction is negative. Negative means downwards. Okay, the acceleration is downwards. So, all right, do you see how do you do these questions? Very simple. That's the difference between the wave speed and particle velocity. Wave speed is you just use the formula v with f lambda. Particle velocity, you need to differentiate. And beware, the list of formula only provide you the sign equation for displacement. If the question gives you the sign equation, you can directly use the velocity equation in the list of formula. But if the question gives you the displacement equation with cos formula, then so sorry, you have to differentiate yourself to get the velocity equation. And be careful with the sign cm and second, the x and y in cm, because once this x and y in cm, that means the amplitude in cm, the velocity in cm, everything in cm, even the acceleration, the velocity, all in cm per second and cm per second square. So these are all the things affected. I hope you be careful. Yeah. Also, the maximum velocity is a omega, maximum acceleration is a omega squared. Do you enjoy my videos? Hope you like and subscribe. Stay tuned for the next videos. Bye.